Let us come to the geometrical application of differentiation here. So you must have come across various types of graph. Let us say one graph is this, that is S versus T graph, and this is a simple straight line here that is parallel to time axis. So if we move from point 1, let us say here, to point 2 here, what is the change in displacement? There is no change in displacement here. So we can simply say that the average velocity between point 1 and point 2 is 0 here. That is very simple to calculate. Now what about instantaneous velocity at point 1 or point 2? So at any point, if we want to calculate velocity, let us at point 1, so we have to draw a tangent passing through point 1. So what is the tangent line looks like? This line is parallel to this axis. So again, the slope of this line, that is angle made with the time axis, is 0 here. So along this line, both average velocity as well as instantaneous velocity is 0. Now what about velocity if the displacement as a function of time is given by, let us say, this line? Can you give some information about the value of velocity here? So again, if we want to calculate average velocity between point 1 and 2 here, so how will you calculate? This is the ratio of displacement, that is this length, upon ratio of time, that is this length. And what is the value of instantaneous velocity at point 1 or 2? So again, at point 1 or 2, we will draw a tangent passing through that point. For a straight line, tangent is the same line. So again, this line will give you the slope at any given instance, and the slope, that is value of tan theta, this will give you instantaneous velocity.
So basically here also instantaneous velocity at point 1 and the average velocity from 1 to 2 is same. And it is 0. And here instantaneous velocity at point 1 and average velocity between 1 and 2 is same, but here it is not 0 but tan theta.
So here the difference between these two graphs is this system or the mass is at rest. Here, since velocity either it is instantaneous at an instant or between any 2 points, this velocity always remains constant. So such type of motion is called a motion with uniform velocity. Now there are other type of motion also, like motion with non-uniform velocity. So how the graph looks like in those cases? So let us discuss another graph in which the motion is not uniform. A graph is given like this. So can you say something about the type of motion here, whether velocity is constant, 0, increasing, decreasing? Can you infer any value about the velocity here? So if I take a point 1 here, let us say, and then I take a point 2 here, and we are going to compare the instantaneous velocity at point 1 and point 2. So how can you find out the velocity at point 1 at a given instance of time? So for this we have to draw a tangent here. So the tangent will look like this line, and this angle, let us say this angle is theta 1. So this theta 1 will give us slope of the tangent passing through point 1. In the similar fashion, we can also draw a tangent passing through point 2, and this tangent will make an angle theta 2 here. So theta 1 is the slope at 1, theta 2 will give slope at 2. So value of tan theta 1, that is slope at point 1, and tan theta 2 can be easily calculated, and it is very clear that theta 2 is greater than theta 1, and hence we can say tan theta 2 greater than tan theta 1. So the velocity at point 2 is greater than velocity at point 1. If we move to some other point, let us say 3 here, then the tangent at point 3 is more than tangent at point 2. So again velocity at point 3 is more. So you can verify from any point that when we are moving away from origin, you can see that the velocity is continuously increasing. So this is a non-uniform velocity motion with constant, with acceleration that is positive here. So the velocity is continuously
So
increasing here.
if I will try to understand by some another graph, if I make a displacement time graph which is little different, suppose like this.
Yes.
So this graph is concave upward and
Yeah.
I have drawn it convex upward.
Upward.
So in that case, if I take the tangent at this point, it will make an angle theta 1, and if I make a tangent here, it will make some angle theta 2.
Theta 2 here.
So the point 1 is having more slope
Yeah.
and point 2 is having actually less slope.
Less slope.
So here, as we are going forward, as the time is proceeding, the velocity
Tan
is
theta 1 is greater than tan theta
yeah, tan theta 1 is greater than tan theta 2. As we are proceeding, the velocity is actually decreasing.
decreasing. So this is a motion in which velocity is continuously decreasing. This is a motion in which the velocity is continuously increasing. So in a real case scenario, we can say that this is a situation when we start our car. So when we start our car, we put our foot on the accelerator, and then there is some acceleration that will increase the velocity of the car. And this is a scenario when we come across a red light and we put our foot on the brake, and in that case the velocity start decreasing. So this graph will give you the scenario when we apply a brake, and this situation will give you a scenario when we start accelerating. So there are some other application of differential as also, and we are keeping those things for the further discussion, and we are leaving that scope of discussion for further. Now, but using all these situations, you can understand that how important concept of differentiation is while you start learning some advanced concept of physics. Like similar concept you have learned in the junior classes also, and when you come to the senior class, the similar concept has some different type of interpretation, and those interpretation can be understood only using the concept of differentiation. So I am giving you one question, and that question can be easily solved if you have learned this concept correctly. And that concept is to calculate the value of force when force is given as a function of potential energy. You must have heard all these terms, that is force and potential energy. So I am giving the relation between force and potential energy. F is equal to minus of du upon